You already know how to do basic long division. For example, if you have 321 and you want to divide it by 7, you set up long division this way. You know 7 goes into 32 4 times. 4 times 7 gives you 28. We subtract, which leaves 4, and then we bring down the 1. We can now divide 7 into 41, which goes 5 times, giving us 35 here. And when we subtract, we have a remainder of 6. You can also think of this as writing 321 is equal to 7 times 45 plus that remainder of 6. We can do the same thing with polynomials. Consider if we're going to divide x squared plus 2x minus 24 divided by x plus 6. We have to figure out how many times we can take this into x squared. Well, I need to get something that matches. So I'm going to multiply by x. When I multiply by here, I get x squared plus 6x. Just like on this side where we then subtracted, we're going to subtract here. It's important to put that in parentheses so that the negative gets distributed. These cancel, and I'm left with negative 4x. I bring down the negative 24. Now I need to multiply by something that's going to match this value here. I'm going to multiply by negative 4. When I multiply by negative 4, I get negative 4x minus 24. Again, subtract by putting the whole thing in parentheses. Both of these cancel, and so my remainder is 0. This tells me then that x plus 6 and x minus 4 are both factors of the x squared plus 2x minus 24. Notice factors mean I can multiply them out. So if I multiply this together and FOIL, I get x squared minus 4x plus 6x minus 24, which does indeed reduce to this value. Now I have listed here the steps for polynomial long division that we just did together. We're going to go through them again in just a minute on another problem. But first of all, you have to make sure it's in descending order. You divide that first term by the first term of the divisor. Remember, this part out here is your divisor. Then you're going to do that multiplication. You're going to subtract, and you're going to repeat that process until the degree is less than the divisor. When we got to a remainder of 0, that was a degree polynomial of 0, so we were finished. Let's look at this process here. We want to figure out how to get these to match. I know I need to multiply by 3, and remember when we multiply exponents, we add them. So this is going to be x cubed. Multiply each term here, so I get 6x to the 5th minus 3x to the 4th plus 9x cubed. Please get into the habit of putting it in parentheses to subtract. These cancel, and I'm left with negative 2x to the 4th plus x cubed. The rest of my terms come down. Now I need a term that will go into negative 2x to the 4th. I need to multiply by negative x squared. When I multiply each term here, I get negative 2x to the 4th plus x cubed when I multiply here, and then minus 3x squared. Again, in parentheses, make everything subtract. This disappears. This also disappears, and I'm left with negative 12x squared minus 19. I need to match that negative 12, so I'm going to multiply by a negative 6, which leaves me with negative 12x squared plus 6x minus 18. When I put in parentheses and subtract, these cancel. Notice there is no x term here, so this just becomes minus 6x, and then negative 19 plus 18 is minus 1. When we write this out now, we know that our quotient is going to be 3x cubed minus x squared minus 6. And then we can write that remainder over the divisor to list that remainder there. Well, what happens if complex values are involved? Don't do anything different. You just have to remember your steps from multiplying complex numbers. I like to list all of my pieces. So I'm going to rewrite this as x squared plus 0x plus I as a placeholder. And then I have x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1. This is just going to make that division and subtraction a lot easier. I need to get this to match, so I'm going to multiply by x squared. I get x to the 4th plus 0x cubed. These are going to all come to 0, and then I'm left with I x squared. Put it in parentheses and subtract. These are going to cancel, and I'm left with negative I x squared plus 0x plus 1. To get that negative I x squared to match, I need to multiply by minus I. I end up with minus I x squared plus 0 ix and then minus I squared, remembering our rules for negatives. When I subtract, I end up with these cancel, and I end up with 1 plus I squared. But remember, I squared is negative 1, so I end up with 1 minus 1, which is 0. Since there's no remainder, we know that x squared minus I is a factor. X to the 4th plus 1 can then be written as x squared plus I, which was our original divisor, and x squared minus I are the factors.